Right now, to kick off the day, it's my great pleasure to introduce Samadnya, who is going to be talking about how to build and develop evolvable and scalable data-centric apps. And so I'm just going to hand over to you. Take it away. Big round of applause, please.
Thank you. Good morning, everyone. If you're here to listen to me talk about enhancing your ability to build applications that evolve and scale well, you're in the right place. If you know someone who would like to enjoy this talk, please invite them over, and let's get started. I am Sam. I also go by Samadnya Kalaskar. Please connect with me on LinkedIn, and we can talk throughout the day. I'll be on the desk right there at Ask the Experts. I am a solutions architect, so it is a part of my job to help customers see the potential of using MongoDB in their solutions. And I just took from my day job and built this talk for you by piecing together a few pieces of advice for all the developers who want to start using MongoDB and build applications that stick and don't really fall apart really easily. Today's agenda is fairly simple. We are all, actually now that we are a really tight group, we're all going to be part of an application, and we are going to be the core team for a hypothetical app that I made up, but it might go live someday. We will then look at how to build a data model that evolves with time and doesn't really fall apart once you have a lot of product features getting introduced to you. Then we are going to think about the best way to index, because that is something which will impact the performance and directly affect your user experience. And last but not the least, since we will succeed, our application will need to scale and will need to grow, and that is why we will see how to use a shard key. Has anybody by any chance tried sharding before with MongoDB? Okay. So yeah, maybe we'll have some burnt fingers, but we will try to see how we can undo that and see how that can get better. Well, let's get started. Yeah, this is an AI-generated logo, so if you don't like it, feel free to give me feedback. This application is called Local Focal. So I want to, appoint myself the CTO, because no one's going to say no. And we are going to build this application for supporting local vendors and connecting them with the technology that they don't have access to, because all these big grocery giants are taking over, and all the bodegas and delis are really going out of business these days. So we want to enable this fast delivery and really good customer experience by building the tech stack for them. And for this very purpose, MongoDB has been chosen as the primary database. And there's going to be a couple of things there, a few microservices, which of course I won't be going into the details of, but there'll be a user-facing web app, there'll be a storefront web app for the vendors, and there might even be a mobile app in the future, so MongoDB can support all of that with the developer data platform. But for the purpose of brevity, we will look at a couple of models for the order schema, which is more or less going to be really easy to understand because it's your regular retail use case. So, why did I choose these three things to focus on? The first one being evolvability of your data model is really important if you're talking about an application which will stick in the future. So think about customers, and we are trying to add new products, and let's say there's all these new agile development practices that come up, but if your data model is really archaic and you're not really making changes to the data model, you aren't probably going anywhere. Your product team is probably complaining about you. So thinking about how can we make this rapid development and bringing new features to market a really great process without tampering the development, developers' time is one of the most precious resources out there. How can we do that is going to be a really key decision-making process for us today. And the second one being a robust indexing strategy. It's of utmost importance that all the customers get a similar experience as they load the web page, as they see your, website and order things, so that they don't complain ever about having a really slow website. So we want to make sure we get the right indexes and look at the most complex queries and how can we cover that using MongoDB's really strong operators or different kinds of indexes and compound keys. And as I said, we are going to succeed with this application, so we might even go global. We might have to add lots of customers across the globe, for the purpose of which we will need to shard. And let's get right into it. I made this meme, so don't judge me if it looks really funny. But what we decide today is going to decide the future of this company, Local Focal. Now imagine we did not choose the right, let's say, indexes, or we did not choose the right schema. 2 years down the line, our lead developer right here, he's going to come to me and say, Sam, we did a really bad job that day. Let's go back in time. The application's broken. We did not choose the right schema. So for the very purpose of solving that issue, let's think about the basics, okay? Are you all familiar with the document model in MongoDB? Maybe by a show of hands. Okay, I see a lot of nods there. So trying to understand the difference between regular tables and how they link, MongoDB also allows you to do that, so you don't reach the maximum 16 MB limit per document, so that you don't have to be worried about like storing everything in one single document, because you can always link it to a different collection if you don't need to query all of that together. So that's the idea. Let's just try to understand that is an option there. But what is really key here is to understand that with MongoDB, if you want to be accessing a lot of data together, the goal is to store it together, and this is how a sample document actually would look like. You can already see it's pretty rich. It's able to store lots of different data types within it. The underscore ID being something that's common to all documents, which you can think of as a unique identifier. But all the fields down below are going to be something maybe like a nested array, nested documents, to make it really versatile for you to store different kinds of data in a polymorphic fashion. And why would we do that, right? As I said, if you want to get everything back in one query, you don't want to look across a lot of tables. You don't want to do those really heavy relational sequential joins, so that you can get all of that in one single response. And as I said, like if you are going to create large documents and if you don't need it, then you can always go back to linking, back and forth. Once we've set this stage with the foundations, let's see the evolvability principles. Now, you'll say, Sam, what are you going to talk about? There's so many evolvability principles. Yes, there are, but these are a couple ones which I think will be important to get you started to think about your journey with MongoDB. The first one being getting rid of the mindset where you need to work for the data. It's actually the opposite with Mongo. You have to design for usage, let the data work for you, think about how you can leverage different kinds of fields and the power of projection. And the second thing here is making sure your updates aren't really creating any overheads for your processes. So we'll just look at a couple of approaches to do it right, and then how can we even think about the right approaches and stick with it. So this is again a UI I tried to build. I'm not a UI expert, but let's imagine we have a microservice which shows like most popular products on our website, so that people know what to buy, people know what's really cool, what's out there, and this has been going great for the last couple of years. But because of our product team wanting to add a couple of organic products to our website, they've asked us to make a few changes to the schema. Let's see what those look like. Now, this is what your ordinary products document would look like. It would have a product ID, it would have a name, a description, some kind of price. If it's a storefront, they will have some inventory count up there, and you will see when this product was added, etc. Now, this team wants you to add maybe a couple more fields like certifications. They want to see where it's sourced from. They want to see what's the origin of this product. But not everything is going to be organic. That's the key here. We are trying to be evolvable. We are trying to adapt to these changes, but not at the cost of changing everything in our schema. Since we have a flexible schema, some products can have this, but what about these underlying microservices? Tomorrow I want to add a microservice which shows really great ethically sourced products we sell, but this one has to now coexist with the previous most popular product service. And if your microservice isn't really aware of these new schema changes, and if you're using a really strongly typed language like Java, C++, where your methods aren't really aware, it can be really difficult for you to predict whether or not the application will break or will it stay, and you don't want to find it out when you go live. So there's a couple of ways to avoid this. Let's say our current code calls for this function called most popular products, in which it looks at your sales count in a descending order, so it knows what's the most sold. And again, as I said, there might be an error out there which will say, hey, if I'm looking at this new schema and I wasn't really aware of the certifications field you just added without telling me, your code's going to be angry at you. There might be an exception here and there, maybe not with JavaScript, but you get the point. And to avoid this, our developers don't have the time to go back and forth, change the code and come back. It's just not going to stick. Our degrading agility will be really visible to all the competitors out there, and we don't want that. So, what can be done? Anybody here familiar with the aggregation pipeline? Perfect. I work with the author of the pipeline, like the aggregation pipeline book, to build this presentation. So yeah, we have the maximum right code out there. The dollar project is actually a stage in aggregation pipeline. You can think of the aggregation pipeline as an extension to MQL. So you're going to leverage that to make these complex queries and project things you want. So instead of writing the thing in your microservice, like in the application code itself, we're actually going to be able to do this in your MongoDB query language using the aggregation pipeline. So what I've done here is, when you look at the most popular services code, instead of now going and changing and adding the new schema code logic, you can simply project the fields you've originally wanted for that microservice. So now, regardless of what fields you add to your schema, it's not going to need it because it's only projecting the fields you would want to see. And it's not going to break now because there's essentially no dependency. You can also use projection, the concept of projecting, within the find query itself if you don't want to go the aggregation pipeline path. Now in this case, as you can see, similarly, everything with a 1, like name 1, description 1, is going to be projected. And the rest of it is the same, right? The sales count, logic, everything else is the same. And this way now, since you've explicitly told it to project these fields, your old microservice is going to work, and we are really agile. We can have as many changes from the product team as we want. Well, to the second point. Now I'm going to talk about updates, right? So think about this vendor portal, the storefront side, where each vendor can see the count of their products and how much stock they have. Maybe they're running low on stock. And in this case, all your organic and non-organic products will actually sit in the same service. Now there's no essential isolation between those, but we have made those schema changes, and we do want our entire code to reflect those every time we update an inventory. A really naive approach, which I know most of you here won't take, is to replace the complete document every time they update the inventory count. I know you won't take it, so our team is actually good, but I'm still going to show you how it could go wrong easily. So let's say this is your replace logic. You take the inventory count, and every time you update the count or reduce it, you're replacing the entire document. There's this smart approach, which our team will take, is to use the in-place operators with MongoDB, such as $set, or in this case, $inc. What this really does is, it doesn't really update the entire document, but it changes just the value for the field without changing underlying document schema or replacing the whole document, which also has a nice performance benefit because now essentially you're not reading the whole thing, you're just updating one single field. Let's see how that could have played out if we were to replace the document. Since again, the code isn't really aware of the new schema in your replace logic, if you haven't really made those changes, it's not suddenly going to know that it has to add these fields, so you will miss these fields in the new update. So maybe your organic products will miss that document with the actual fields it had. Instead, we want to make sure we need to be aware of the new information. We need to be resistant to such changes. So you use the $inc, and yay, this all retains, and our document looks pitch perfect, and we're good to go. So these are just a couple of evolvability principles. As I said, my mentor actually did a really advanced talk, so I have plugged in the QR code at the end. So feel free to dive in deeper. But let's hop on to the next session quickly, thinking about indexing. Who here can choose an index within the first go? I see no show of hands, because I don't think anybody can. You have to reiterate, you have to think about the best strategy. And I think the best part about thinking about indexing is to think about your users. Everybody says, oh, we are really customer facing. You have to actually be customer facing when you choose indexing, because you would want to address all the most common queries and think about the access patterns and what exactly matters in terms of retrieving data. So in my time in the field, I've learned this golden rule of indexing, which I'm excited to share with you, but I'm not going to give it away just yet. So we are going to go through an exercise of coming up with a really good index key for our application, local. So let's say this is one of the most common queries which we see all the time: get a user's 5 most recent orders with the status pending. Because I'm a really anxious user, I always want to see where my order is. Is it delivered? Is it pending? Is it on its way? Maybe something like that. Now in this case, who thinks building an order status as an index is a great idea? Yes, I said, we are smart people here. So let's see what happens if we choose order status as the index. Let's say this is our order schema. This is just so you understand, what the context is, because I know I wrote this code. But it's a regular, pretty much like order schema with your unique user ID. You have these items. Now, for the purpose of brevity, I haven't really added a lot of items. But MongoDB can store an array within this document. So imagine like there's multiple things in your cart. That's where those items would go. Currently, we only have organic honey. And then you can see there's this thing called order status, which is, again, as I said, could be a potential index. Not sure if it's good or bad. And then there's the total price and created at, meaning when was this document created. So a few of these fields are going to be really good candidates and maybe really bad candidates as an index key. So thinking about this single field index on order status. As I saw, no one really agreed with me when I said we'll use it. The reason is because we haven't really eliminated as many fields or document searches as we should, because we're essentially doing an entire collection scan to find everything that has a status pending. And then we're again trying to filter everything with a user ID of our choice. That is not really a very efficient way to do this. So there has to be a better way. Who thinks we should do this with user ID as an index? Please, by a show of hands. Okay, I see 2, 3. You will all get brownie points. If we use user ID right here as an index, it will now narrow it down to a specific user, and you only have to go through a few documents for order status pending. If this person hasn't really ordered more than 10 orders, it's a really easy query. So now you've saved all that time. But you see this sort right here. Everybody who's aware of sorting and how sorting can go wrong, pretty easy if there's a lot of documents, you're going to know that there's probably a better way to do this instead of sorting in memory. Essentially, imagine if I were a user who orders 600 orders a week. I really eat a lot of chips. So if we were to sort my orders in memory, it would have to rearrange everything for those 600 documents, even if it all has the same status. And we don't want to do that. So what can we do? How should we go about it? Anybody want to just blurt an answer out? No? Okay, I'll share you this is the secret, using a compound index. So using a compound index, what's going to do is it's going to create a sorting index with created at as one of the fields in your index. So with this, what really happens is everything comes in and gets stored in the index with the sort on the created at date. So now you're never doing those runtime sorting operations and making this really performant and not really slow, because as I said, this has direct impact on the customer's experience with our website. Now, this is a great takeaway, is to basically think about your queries and think about your patterns where you would probably benefit from a compound index key than a single field index. But we're here for a really great talk, so I'm going to take it up a notch. We're going to look at a query which does have one more complex criteria, meaning a range query. So this is something really common too. Maybe I am a vendor who wants to give discounts to my most splurgy customers. So I want to see, let's say for this specific user, find the 10 most recent orders where they spend more than $100. Now we have introduced this new number, more than $100. We all know how to do compounding for the 10 most recent orders for this user, but what would you do in this case? You leverage the equality operators in MongoDB. Since $100 is not going to be a specific field yet created, we know that there's a field called the total, which will show us the total price for our orders, and we can actually leverage that to compare it with the number 100 by using a greater than operator. Perfect. I think it sounds perfect. If you see this, user ID is still there. Now we've introduced this total, which is going to look at our total field, see the value, compare it to 100, and yay, we have all these documents where the user spent more than $100. And again, the index looks perfect, right? Who agrees this is the best way to do it? Okay, I don't see a lot of head nods, so maybe there's something I'm hiding from you. There is. If you see the previous slide, and I'll again go ahead, the total in the index is in the middle for this one, because we follow the pattern in the query itself, and the total in this one is at the end. And I'm saying that you should follow equality sort range to get the most optimum performance. Now the reason why I say it is because in the previous example, if you were to have this index order in this fashion, You're essentially now taking all the users, then going through the one you want. Once you have all the data, you're going through the entire documents where you're comparing it with 100. But now essentially what you're doing is you would still need to sort these documents. And again, if you've 600,000 orders, you're again creating a blocking in-memory sort regardless of there being a sort index. So what I mean to say is that the order really matters because equality has to go first. Then you talk about the sort, and then we deal with the range. It is something that might not sit with you, easily at first, but once you start implementing this and you see the performance optimizations, ESR actually fits with most of the use cases unless it's something really specific. But as you can see here, when we do that, the range being at the end is actually just going to help you narrow down your search. Essentially, you're sorting beforehand, so you might just have to look at the first 5, as I said, if they only have 5 orders. But we're asking for a limit. So a limit, like limit of 10, a range where it looks at numbers, they're all going to go to the end. Perfect. Now you say, Sam, after local focal, I want to go build my own app. How do I identify ESR? So here's a quick message. Order matters. Anything that has an equal match in your document with an exact value is going to be the equality field. Anything which will help you get the represented queries results is going to be the sort. It usually is like time or date that can be arranged in an ascending or descending fashion. And then the last thing is your range predicate, in which it's nothing that exactly matches to the fields in a document, but there's a way to find that. And yes, this is how we do ESR. Who has tried indexing before but not used ESR, maybe got burned by show of hands? Okay. I tried it too, and yeah, it just has a drastically different result when you do follow ESR. And yeah, let me know if you try it after this, as you've already connected with me on LinkedIn. But let's go to the last topic of the day. Choosing a shard key that scales. Now, who here doesn't really know what sharding is? Okay, one. Everybody else knows what sharding is? Okay, perfect. So I'll quickly explain it for him. So sharding in MongoDB is actually a way to distribute your data once you start to scale. So think of it like you have maybe tens of TBs of data, and now you're like really using all the resources on this one hardware, where you would actually benefit if you were to distribute the data in chunks and essentially increase the throughput, because now each chunk will have its own dedicated replica set. And now that replica set itself supports all the operations just for that data. And now we have created this highly available, multiple replica set structure, but not at the cost of your data being really, everywhere all at once. You, being the user, is completely abstracted away from this process that does the sharding. So your application doesn't really have to be aware of what's happening and which data has gone into which shard. That's all taken care by MongoS, which is the process that shards. And we also keep track of everything in case that we need to rebalance the data. All you need to do is choose the right shard key, which could sound like a big task, but let's try to see how we can do that better. Oh. And then, as I said, why would you use sharding? Think about our application, Local Focal. We are famous. In 2 years, we are going to be really global. We are going to have lots of users use our application. And now think about lots of users. Maybe there's a couple of reasons, right? There's maybe a few users in Europe, and we need to now comply to GDPR regulations. Sharding can be used for that very purpose. You can have zone sharding, in which you essentially create shards or chunks which are unique to those zones, so your data never really leaves, and you've created this sort of data locality also by leveraging sharding. And maybe there's the other reason, right? We have so many users that they're facing really slow response times, because now you have to go get back. So we've essentially now increased throughput by creating multiple shards. Again, the way MongoDB shards is by using a shard key. Now you'll ask me, what does the shard key look like? Now that's completely up to you. The shard key is actually a part of your document, the one we saw earlier. It can be any field or a combination of those fields. And depending on your most required queries, you would be able to choose that. And once that shard key has been chosen, that's exactly what MongoDB will use to divide your data. Sharding clear? Perfect. Now, there's a couple of ways to do this shard key. Like, there's different ways. As I said, there's zone sharding. There's range sharding, in which you specify, let's say we have users 1 to 1,000. 1 to 500 on first shard, 500 to 1000 on the next shard. That's range sharding. There's also something called hash sharding, in which if you don't have a field or a clear choice to define, okay, how do I give a range to MongoDB, we use a hash function to do this for you. But that's beyond today's purview. We will focus on range sharding because that's the one which is most commonly used. So let's see what actually comprises of the ideal range shard key. If you have a good shard key, you've made sure that it's cardinal. It hits this cardinality criteria, which we'll be taking a look at. Then the second is the read-write distribution. Third one is read targeting, and the fourth one is range query locality. I will be explaining all of this before, but since most of you said you know what sharding was, how many of you have sharded before? By a show of hands, has anyone tried sharding? Okay, 1, 2. Did you succeed in your first attempt? Oh, okay. So if you haven't really sharded Mongo, this is your go-to talk. Let's think about this document again. Maybe most of you know this by heart now, but this is our orders document in which you have your user ID, your order schema, in which you have your specific product details again. Some of you have noticed, or maybe you haven't, there's a new field I added there, member status. We are an evolvable application. We keep adding new things. Member status is one of the new fields we added to introduce this premium feature for our users who can pay like extra money to get early access, fast deliveries, etc. So let's say we decide to shard based off of this member status field. Meaning, anyone with a member status of, let's say, VIP goes on one shard. Anyone with a regular member status goes to the other shard. Who thinks this is a great idea? Show of hands. Okay, no one. I said we are really smart. So, as you can already see, the left-hand side is already really heavily unbalanced as compared to the right one. Well, I did say earlier that MongoDB does rebalancing for you. MongoDB, it rebalances so that all your chunks are even. But essentially, you have completely taken that option away from Mongo by giving it a shard key that just cannot be, sharded like that. Because there's only going to be a few VIP members because no one really likes to pay extra for premium. I use free services all the time. So as you guessed, this isn't really a great shard key. So let's see what is. This one, as you see, right, it doesn't even scale well. Maybe by 2026, people still don't want to pay for VIP member status. It probably will always be unbalanced. But user ID. We all know we are going to keep adding new users. We all know user ID is actually really unique. And what I mean by cardinality is a field that can potentially take multiple values, and it has these unique values so that it's really highly cardinal. So if you think of something that's really binary, something that only can potentially have a couple of values, it's probably not a great way to shard because you're again creating these two shards, which again doesn't give you the throughput you really desired and the original reason why we sharded. But with the user ID, MongoDB can keep rebalancing your users as it goes on different shards. And yeah, it'll scale well. It looks really perfect in 2027 as we grow because the users will keep growing. We'll have more unique values. So is that all? Is that all we need to choose a shard key? Probably not, because I had 4 criteria to meet. So let's look at the next one. Read-write distribution. So when I say read-write distribution, you want to think about, multiple parallel independent incoming requests. And if you create a timestamp-based shard, okay, imagine a query like, get me my 5 most recent orders. Okay, I know your recent orders are on shard 4 because let's say we keep all the recent data yearly. So shard 1 will have 2023, shard 2 will have 24, 25, 2026. Since we are sharding in 2026 in the future, if I still keep looking at my recent orders, I'm still hitting this one shard, creating a hotspot. So you don't want to create a hotspot shard because, as I said, it makes your entire sharding process fully redundant because you're still not reaching the throughput maxima you can. It's not a good shard key. So what will be a good shard key? User ID, right? Because in this case, with your, really bad read-write distribution, you have created this really bad read-write distribution graph right here. As you can see, all your reads and writes are going to this one last 20, 26-year shard. We don't want to do that. With user ID, let's say I want my data to come from shard 4, someone else's data will come from shard 3. Essentially, all the shards are getting utilized perfectly well. So you're now leveraging the power of sharding and now leveraging the response times, because even though there's parallel operations, me and you, we're all looking at our recent orders, MongoDB is not going to the same shard by avoiding the hotspot shard creation. And yeah, we've really avoided the whole collection scan by sharding. We've really now gotten to a point where we are getting really good response times, but there's still a couple more criteria to hit. This is what the graph looks like if anybody's curious. It's perfectly balanced. But yeah, the third one was retargeting. When I say retargeting, let's say again we have done a created ad shard. This is what the shards look like. And I say, I want to see how much money I've spent on organic honey in the past 4 years. I really love eating honey, drinking honey. Okay, so we are looking at that, and what you can see is, even it's a simple query that asks for my spend across 4 years, my MongoDB server will have to go into all shards to get that data for me, because my data from 2023 is in that shard. My data from 24 is in this shard. And this again is doing a scatter gather query across shards, and you don't want to do cross shard queries. Maybe you want to do cross shard queries for like maximum of a couple of shards, but if you have like tens of shards with lots of data, you are not really solving the problem that we started to solve. So again, we've realized that created ad is a really bad candidate for sharding, but user ID again, user ID seems like the star of the show. It's taking everything, it's taking my thunder away. Simple query like get me my recent orders. If I am a user with all my data stored on shard 3, this simple query will only hit one shard, which will have great retargeting. Now we've targeted the exact shard we need to target, and it's also reduced the overall response time. And again, you can go back and forth with finding different user data. It could be different orders. It's all stored in my document with my, like embedding the document where it's all accessed together, it's stored together. So that's really perfect. I feel like so far so good. User ID seems great, but there's a fourth criteria we need to meet, and that's probably going to be the decision-making skills, where we all have to come together, get our heads together, and see what actually sticks for local focal. So no bonus points for guessing that this isn't the only shard key that we need to make. We need to think about range query locality. Now this one took me a couple of minutes to learn, so let me piece it down for you. Range query locality comes into picture when you're trying to do queries where there's a range involved. The one we saw when we were looking at the indexing strategy. Let's say there's this user who wants to see their spend across years. Maybe they want to see their most recent orders where they spent more than $100 again, or they want to see the last 10 orders. But this user, if they're a really prolific user, there's a chance that their data got rebalanced by MongoDB on a couple of shards. So far we've seen examples where each user had their own shard, but if it's someone who's really, really using our application a lot, there is that slight chance that their data got spilt over on a couple of shards. So if our shard key is now user ID, we still are going to need to do cross-shard queries if I'm trying to find my 10 most recent orders, because there is a chance that it could have stored last 5 orders on this shard, but like all previous orders on some other shard. So having user ID as the sole shard key might not be the solution. So sorry for user ID, but we will need a compound shard key. Now you'll see why. We've been looking at created at, right? Like if you think about a compound shard key, you combine essentially your user ID with created at. So now even though you know that my data spilt over a few shards, my recent data is actually going to be on one shard, and using that created at index, we have solved the problem of doing a cross-shard query without having to look across the multiple shards. So I'll let that sit, and of course, if you have any questions, we can discuss those in the last 5 minutes. But the idea behind this is that think about your sharding from a point of view where you don't want to do all the things that I just said. You want to make sure you hit those 4 criteria. Now this is a generic example. This team here for local focal, I feel like we've done a great job but I know all of us are talented developers or any title you have, and we need to make more applications. And to make that decision of choosing a shard key easier, this can be a typical good shard key formula, where you think about this compound shard key, where the first half of it takes care of the cardinality. It could be something that's really unique, something that can have multiple values, like a user ID, employee ID, some sort of a random ID, and then combine it with something that's sequential, something that can affect your sorting, something that can affect your range queries. And with that way, you can hit all these 4 criteria that we've been trying to hit for the past 10 minutes or so. Also, as I said, I am a solutions architect in MongoDB, and I help my customers see the potential with MongoDB. So this is a great way for me to showcase the versatility of MongoDB. With all the other databases out there, or even like with MongoDB before 5.0, people used to be really scared to shard. Because as you can imagine, we went through this exercise, but since we are building apps that evolve all the time, there's new things that come up, a shard key may not always stick. And if you realize that, oh, the shard key we decided on June 22nd, 2023 was really bad, you probably have to take the entire data, dump it, make a new shard key, restore it, which could go on for several days. And that's not really what people want to do. So they just would really be scared of sharding, and they kept slapping more hardware, kept adding more hardware, kept adding more vertical scaling. But it's not really cost effective. Whereas sharding, if you do it right, can choose, you can choose to solve all your problems with throughput, maximizing resources, as I said earlier. So MongoDB came up with live resharding, in which you can actually reshard on the go without any downtime. So, if you want to change that shard key you chose today, you can do that. So there's lots of peace of mind when you make that decision to shard. And another really interesting thing is you can test different keys, you can see how it actually plays out, and you can have multiple combinations. What I mean by combinations is, as I said earlier, range sharding is one of the ways to do sharding. There's 2 more ways. There's zone sharding and hash sharding. So you can actually make a shard key with a combination of a hash and a range, or a range and a range, and that way you really have a really robust sharding strategy. So having said that, local focal, I think we're pretty good to go. We've made these decisions today. Let me reiterate those. Having this evolvable data model, this is true to every application. Your data model should be really flexible, but for you to have that flexibility, you need to leverage all the projections, all those updates, making sure you're leveraging MongoDB's query operators and taking care of all your complex queries without having to go back and forth between the dev team, the prod team to go change the application code. Because trust me, no one really likes to do that. And now you're in a degrading agility, downhill kind of a graph. So we totally avoided that by choosing those accommodation of future changes without disrupting the existing application. The second thing we really saw was the indexing strategy. Can everybody maybe do a shout out the rule for me, maybe the abbreviation of the golden indexing rule, if anybody can? ESR, okay, I hear it. It's okay, that's enough. So ESR, as I said, equality, sort, range, keep that order in mind because the order really matters. We saw that by choosing the right indexing strategy, we can actually make sure that our queries are really optimized, fully fast, and don't really give that bad user experience where you have to wait for the page to load to see your past orders, because we all hate when that happens. And last but not the least, we are ready to grow. We are really going to succeed. And sharding is the way to go if you want to scale, if you want to add more users, if you want to accommodate a global audience. As I said, the reason being really high throughput, being able to distribute your data, and not really having to worry about which data goes where because MongoDB abstracts that information away from you. Well, I do really good puns, sometimes bad. This one's a good one. So it's time to Mongo. We all have some work ahead of us as the core team of Local Focal. As your CTO, I'll be signing off after this, but our grocery delivery app will not stop. It will be a global success, as I said. Feel free to scan this QR code if you would like to give me some feedback. And as promised, there's one more QR code after this which I will be flashing, which has a really detailed advanced agility topic from my mentor who helped me build this presentation. But thank you so much for all your time.
Big round of applause for Sam, please. Yeah. You're going to take questions? Okay, so we've got 5 minutes. That finished a little bit early. So if anybody's got any questions, if you'd like to raise your hand, I will come and bring a microphone over to you. Any questions? Okay, we've got one question in this row.
Yeah, so that fourth criteria for the sharding that you mentioned, it was the locality, or I can't quite remember the term, but how does Mongo decide when it's going to rebalance things with that have the same value on the shard key? Yeah, so when... Okay, so that fourth value, range query locality, how does it decide if it's like the user ID is identical? How does it decide that, okay, I'm going to put this with the same value on a different shard? Like, when does it make that decision?
So think of it like there's like really unbalanced shards at this point where this one person has ordered so many orders that they are actually skewing the results. MongoDB is aware of that, like seeing that this can be balanced using this unique shard key. So they can actually spill that, like it can actually spill that over for you. So essentially it will have to do that cross shard query. Yeah. And I will be at the Ask the Experts booth from 11 a.m. So if you have like questions that come up later, feel free to say hi.
Any more questions? Any more questions? It's very early in the morning. Oh, we've got one more question over here.
So what if you want to print out the like multiple users? Like assume you want 10 users, and let's say list of users who have ordered like more than 50 times in the last 1 month. So and each user is in each shard. So will it go through all the 10 different shards to get the same thing which you had previously in yours?
Because, oh, sorry. There's this one user whose data can be spilt over because they are a prolific user, right? So 10 users. Okay. Okay. Yes. Yes. Mm-hmm. But if you have the created at, so I mean, yeah, we are doing parallel processing. There will be data, but the goal is to not have all those queries go to one shard itself. Now you're distributing the workload, so you're essentially like, you'll see more throughput. A different
combination of...
Yeah. You could choose different combination of keys, but this one actually sticks because if you saw the first half of it, like the user ID created at, actually overlaps with our indexing too. So that's already like kind of a validation check to see if your shard key is good. Yeah. Yeah, definitely. So as I said, like you want to think about the access patterns and the most common queries at all times. You don't want to do a corner case and choose the shard key and indexing for the corner cases. Yeah. You want your most popular queries to be covered first and then think about the other ones. Thank you.